So next step in vector components to see how can we find a vector if we know the components. So pretty much the idea is if I have a, actually let's write it so our task here is find a vector A, which means to find a vector A, I need to find the magnitude and the direction of vector A if the components are given. All right, so in general, if we have here y and x, remember the y and x could be north and east, could be up and right and left, could be any directions, all right? So let's say we have a vector A, sorry, we have the components, so let me do them in a different color. We have the components like this. This is AY and AX, then this is the actual vector. So we're looking for how magnitude of vector, which means a hypotenuse in this right angle triangle, and some angle for a direction, either with the y-axis or with the x-axis. It doesn't matter. It's just a matter of choice. All right, so let's start. So remember, knowing AX and AY, so if given is AX and AY, then required is A, the magnitude of A and the angle theta. So if I have to solve this, the analysis, so given required analysis, pretty much we're going to use Pythagorean theorem to find the hypotenuse, which is a magnitude of the vector. So to find A, and we're going to use tan ratio to find the angle. All right. So the magnitude of A will be square root of the sum of the square of the sides, and the angle will be the inverse tan of opposite over adjacent. In this case is a x over a y, but in a lot of other instances could be the other angle between, could be this one here, right? So it depends in which one would you like to report. So here's a quick example. So if you have, so given is a vector A x equal to minus 25 and AY equal to minus, I don't know, 50 meters. And what we want to find is, again, the magnitude of vector A and a direction angle for vector A. All right. So usually what I like to do always, as we're going to find out in physics or in math, I like to draw it. So minus 25, the AX, and minus 50, the AY, means that vector A is on third quadrant. So what does that mean in compass direction? It means it's somewhere in the southwest direction, right? But remember, X and Y, it's better because it's just abstract and you can pair it with whatever concrete directions you're dealing with. All right, so let's draw it. So here is a Y, and here is X. Actually, X is only half, just so we can have a clear idea. So this is AY, this is AX. Our vector is like this. This is vector A, right? So we can report any angle we like, just to give you a different perspective from before. let's say that we want to find this angle, which we all realize is the same as that one, the Z pattern. So which means with respect to the negative x-axis, right? So I'm going to do them in dashed lines. These are the axes, right? This is y, this is negative x plus x. So y could be north, could be whatever. All right, so let's find, I'm not going to do the numerical answer. I'm just going to say, well, the magnitude of A is negative 25 squared plus negative 50 squared. And then I'm just going to leave it like this. We can, no problem doing the math there. And the angle theta, so let's say this is the theta, in this case is inverse tan of actually AY over AX. Okay, we don't have to worry about the signs because we already know where it is. So theta is inverse tan of negative 50 over negative 25. Again, you don't have to put the signs there. They are just directions. So it's inverse tan of 2. So it's something definitely more than 45, probably around 75 degrees, I don't know. And then we can report the angle and the magnitude once we find them. All right. So next, now we're going to do a few examples. So let's pause this.